In some projects, for example in the game development industry, there are certain limitations imposed on the face count of geometry objects. Let's assume that we have a scene with some geometry objects and want to find out which ones have a higher polygon count than allowed. Every geometry object, with one single exception, has a property called mesh, which returns the try-mesh value evaluated on top of the modifier stack, but just before the node transformations and the space warps. A try-mesh value is a max script value which stores the information typical to editable meshes, including triangle faces, vertices, edge visibility flags, smoothing groups, material IDs, texture vertices and faces, and so on. There are also some properties related to the try-mesh value, which return the number of vertices and faces in the mesh. For example, numVerts returns the number of vertices in this object, and if we would compare it to the object properties dialog, it is the same number reported by 3ds Max. The property numFaces returns the number of faces in the object. In this particular scene we have different types of objects, including primitives, editable meshes, editable polys, primitives with modifiers, and so on. In every single case, the evaluation of the try-mesh happens on top of the stack, and the number of faces returned is the number of triangular faces, which means that in the case of an editable poly, the result 300 faces is different from what the object properties dialog is reporting, because it's showing the quads in the editable poly and not the triangular faces. If we would convert this object to an editable mesh and take a look again, then the number reported is the same as the one we're getting from the try-mesh value. Using this property, we can create a for loop for all in geometry, where all mesh numFaces is greater than, let's say, 1k. Collect the object, and we can select now all the objects that have more than 1024 faces. In the case of the first teapot, the number of faces is actually exactly 1024, so if we want to include objects that have exactly as many faces, we can ask for the objects that have greater or equal to 1024. In this case, the script selects all the objects that have more or exactly as many faces. As mentioned before, there is one exception. The target object used by cameras, lights, and the tape helper is of geometry class, but does not have a valid try-mesh, as it never renders. It is also traveling between the different object sets depending on who is using the target. In this scene, we have a camera 01, with a target called camera01.target. The class of this target object is target object, and the superclass of this object is geometry class. This means that this object must have a mesh property, and it actually returns a try-mesh value, but trying to access the number of faces of this try-mesh throws an error. This could cause lots of problems when looping through all the scene objects and checking by superclass without explicitly checking against the target object class in order to exclude it from the loop. Let's take a look at the geometry object set. This prints the 3 boxes, the 3 geospheres and the 3 teapots, but does not include the target object, which is, as we saw, of geometry class. If we would say for O in objects, where the superclass of O is equal to geometry class, to print O, in this case the 3 boxes, 3 geospheres, 3 teapots and the camera 01.target have been printed as geometry objects. That means that if we would use this syntax in order to filter by number of faces, for example, we would get an error message. Let's take a look at the object set cameras. It returns both the camera and the camera target, which, as we saw, is actually of geometry class, but is currently inside the camera's object set. We could create our own standalone target object. This object, called target01, is again of geometry class, but if we would now take a look at the geometry object set, this new target is printed as a geometry object because it is currently not being used by any camera or any light, and there is no reason to travel to another object set. Normally in MaxScript, when you create let's say target camera or target spotlight, you have to create the target object first and then assign the target object to the corresponding camera or light. So we can say, for example, target camera is a target camera with a position somewhere around 100, 100, 100, and once we created this one, we can tell the target camera to use the object T that we created, the target01, as its target. Now, at this point, if we would print again the geometry object set, we get again only the boxes, the geospheres and the teapot, and the print cameras returns the original camera, its target, the new target that we created, and the camera 02, which we also created using MaxScript, as objects inside the camera's geometry set. That means that the target 01 moved from the geometry object set into the camera's object set the moment it was used by a camera. Obviously, the 100% foolproof version of a script checking for number of faces would look like this. Select for O in geometry, where class of the object is not target object, and the number of mesh faces is greater than 1k. Collect the objects. In this case, we're getting the same result as before, but if we would create a new target object in the scene without a camera and code this script, there is no error message related to this object. If we would remove the check against the class and execute again, we get an error message the moment we try to access the number of faces of the target object. This shows that it's a good idea always to check against the target object when going through geometry objects, just in case.